Hi there, so I'd like to introduce my latest Arduino build, which is this internet controlled relay which is going to be used to turn my central heating on and off. At the moment nothing's connected up because I thought it would be easier to show you the components before there were wires everywhere. So looking inside, we've got an Arduino Nano just up at the top there. We've got the Ethernet interface here, which is a W5500. We've got a relay board with 4 relays and associated driver circuitry. We've got a power supply for the relay coils, and we've got a real-time clock module over there. So it's all finished now. It's ended up quite neat and tidy, despite for some weird reason the box I bought being much smaller than I thought it was going to be. So I always want a nice spacious box for projects, and it always turns out everything's all crammed in. One problem was getting access to the USB on the Arduino Nano, which is down there. There wasn't really a way on the box of having it so it could be accessed externally, but then I forgot that this Ethernet board would be quite difficult to remove because of the way it's fitted, and the Ethernet socket gets in the way of plugging anything into the USB port for programming in the Arduino. So I ended up hacking apart a micro USB cable and putting this heat shrink on it, and I could just about fit it in doing that. Yeah, so it's all wired up. We've got some cable glands here which are going to be for the mains cables going in to the relays. We've got our Ethernet cable going away to my broadband network. We've got a plug top power supply which powers the unit. So that's 9 volts, 1 amp, and the Arduino is powered directly off of that. The other components are mainly powered off the 5 volts output of the Arduino, except for the relay coils which need higher power, which would burn the Arduino out. So we've got this other power supply set to output 5 volts for the relay coils. We've got our little organic LED display here, which is just displaying the relay states, which are also indicated by LEDs on the relay board, so it's really a bit superfluous at the moment. But in time I want to add a menu system to this, which will be operated by these 2 buttons, which don't actually do anything at the moment. They're connected up, but the code doesn't allow for them. Then we've got this switch, which is some security on the Ethernet. It just turns on and off the response to Ethernet commands in the code if that switch is turned to off. We also had a real-time clock in there wired up but not yet used, and that is probably going to be used eventually for controlling my central heating dependent on time. So basically the relays will be wired across my existing time clock for my central heating. So if I've been on holiday for a while, I can turn it on remotely via a website rather than having to reprogram the time clock before I go. And it's only a 7-day time clock anyway, and I might want to control things over a longer period than that. So I've written some instructions on the device, and I've added a section onto my Arduino website, which we can see here, Ethernet controlled relay, and you can see the URL at the top of the screen. So we've got links to the notes, which are a PDF document. So they go through how it's all wired up, and but then the majority is how to get things working over a public network by setting up port forwarding and dynamic domain name service. And the other link here is the link to the Arduino sketch, and we've also got a link to the library that I'm using for the organic LED display. The other libraries you need are all just standard ones that come with the Arduino development environment. So there's the Ethernet one. You need a fairly up-to-date version of that to be compatible with this Ethernet board, the W5500. and then one for SPI and one for I2C communications. So I'll just demonstrate how this works now. So in a website, you navigate to the URL which you've used for the device. If you're just on your local network, this will be the IP address you've assigned it in the code. But if you're accessing it from a public network, this is where you need to sign up to a domain name hosting service such as NoIP, which I'm using here. I've got my web page full screen so you can't see the address because I don't want everyone logging into my heating system. But the first thing it does, the Arduino returns this web page, which is just a password prompt. So I can type in the password if I can remember it, and then when you've logged in with a correct password, the Arduino returns this web page, which is the one that lets you control the relays. So there are 4 relays on that board, and each is controlled independently here. So if I press relay 1 on, hopefully you heard a little click there. There were actually 2 clicks because the thermostat on the wall coincidentally went on at the same time. We should now see that the display says that relay 1 is on, and that's also indicated by a red LED on the relay board down there. There are various LEDs because lots of these modules come with a power LED. There's one on the Ethernet there, one on the power supply there, some lights on the Arduino itself here, but the 4 along the bottom here are for the relays. So if I turn relay 4 on, see that lights up, and I can turn it off again. So this is my website doing the control, and this so you could be in Spain in an internet cafe and controlling your central heating. The only other thing that's worth talking about in a bit of detail is how the password protection works. Now this took me by far the longest of the whole programming for the project. Everything else went pretty smoothly really. I did have some problems with communications being a bit sporadic at first because I'd missed out an initiation of the Ethernet board, which was missing from some examples I've been copying from. Yeah, but doing this password protection really took more effort than anything else. So by default, the web server on the Arduino will always return this login prompt by default. If there's no other data in the URL indicating a command to do something, the Arduino will do this password prompt. The password itself is at the moment just hard coded into the Arduino, although you could have it programmed however you wanted really, to be generated in some sort of sequence or obtained from a file on an SD card, something like that. If when you log in the data appended to the URL by that password login prompt matches the one stored on the Arduino, the Arduino will then respond with this web page, which is the one with the buttons for controlling the relays. If I hover over one of those and carefully not reveal what the URL of the page is, you can see that data there, which is going to be appended to the end of the URL generated by this button, has a number which is a session ID, that 91982. Now that session ID was returned, it was generated by the Arduino when the login attempt was successful based on the current timer setting on the Arduino, so it's random, and then written into all the web pages that it issues from there onwards. And then it will check that session ID against the one that it's stored on the Arduino when it generated it, and it will only do these commands if the session ID is valid, and the session ID will expire after a minute or so, forcing you to log in again. So that's the rudimentary password protection system, which is probably adequate for this application of controlling my central heating, since the code will only override it for a maximum of 2 hours anyway and then turn the relay off again. So there's not really any problem if anyone goes in there and starts meddling with the central heating. If you were controlling your garage door or something a bit more security critical, then you might want to think about a much better password system than this one. If you're just using the Arduino to return some sort of benign data, such as data from a weather station, then you might not be worried about password protection at all, because why would it matter if anyone can see the temperature in your house or something? Well, that's it. If you're interested in building your own Ethernet controlled relays, then just have a look at the notes on my website. Thanks for watching.